Hi everyone, I'm Eli Schilling, Director of Product Management for Oracle Cloud, and today I wanted to spend a few minutes chatting with you about the different software development models. Today we'll focus specifically on the two more common models, Waterfall and Agile. Waterfall is typically considered more traditional, almost think of this as a legacy development practice. It's a bit more structured, a bit more rigid. And oftentimes the waterfall software delivery model takes a significantly greater amount of time to produce and deliver an application. Oftentimes we might associate waterfall with on-premises applications, monolith style applications, which we'll get into again in just a moment. On the Agile side, we're looking at a much more efficient, much more versatile development practice, which often associates with cloud-centric style development or cloud native. What we're looking at in this regard here is what we would typically refer to as a service-oriented architecture, or more commonly a microservices architecture. That is, we're taking and decoupling the components that we might find in the monolithic application and producing several smaller application pieces that work together to deliver the full application function. Now let's start with the waterfall approach here and kind of talk through how that delivery process works. We're going to start with gathering requirements. And this process typically takes weeks, if not a little bit longer, because we have to go and collaborate with our business stakeholders, our technical stakeholders, our project team, and gather all of the information about what is this thing that we're going to produce. Once we have the requirements gathered, we can then waterfall down and begin the design process. This design process then incorporates all of the requirements we've gathered, and we take those and we build out the functional and the technical specs that articulate what it is our developers are going to create for this application. Once those specifications have been fully defined, we can pass those off to the developers, and the developers will take and build the application. This again takes typically weeks, if not a little bit longer. The development cycle could be months in duration, depending upon how much code we have to produce. Now, once the development process is complete, we're going to be moving on to the test phase. And the test phase typically involves things like system integration testing, user acceptance testing, regression testing, which again takes several weeks to combine, build, test, and validate all of this code. If all of those test cases pass successfully, or at least to the point of producing a minimum viable product, we can go ahead and deploy that code. So we'll hand it off to our operations team, and we'll deploy that code into production. The deployment process is typically rather cumbersome. We're deploying this big monolithic application, so it could take an entire evening, up to an entire weekend, to take that system down and deploy the new code. Once that code is in production, we will begin to operate, so support and maintain in an ongoing fashion, reporting bugs back to the development team, where we enter the support and operate model of the application lifecycle. So all in all, we're looking at a fairly lengthy delivery process in the waterfall approach, sometimes from months, possibly up to even a year in duration to go through that entire process flow. And again, what we're typically building here is this monolithic application. So that monolithic application is a single app stack that incorporates all of the functions into a single holistic component. So this could be reporting, authentication, authorization, user systems, analytics, all of the components that are delivered to the customer or the end user being managed by a single application stack. Now, let's take that monolith and let's break that apart. What we're going to be doing on the Agile side is building more of again, microservices or service-oriented architecture type application. So let's take each of these pieces and split them out into their own application component. So here we're going to have reporting, we'll have our authorization authentication system, user management, maybe we'll call this billing, and one other component over here. And in this scenario, we're going to be applying the Agile software development model to each of these components to deliver them potentially individually in separate parallel streams. Now, just to quickly articulate here, all of these application components now integrate or communicate with each other, typically using API or direct API calls to send or request information from the other part of the application. So they can very easily communicate across the network or even within the same compute resource to gather and share information and eventually deliver a very holistic customer experience. So taking that microservices style architecture and applying it to the Agile software development approach, we're still going to gather requirements, but we're going to do this in a slightly different, slightly more iterative approach. We want to get as much information as we can to start the project. And we're going to capture those requirements in what we call our backlog, or our parking lot. And these requirements not only include functional specifications, feature requests, design considerations, but they also include considerations for deployment, operations, and management of those applications after they've gone live. We also factor in things like bug requests or bug issues that are discovered after the application has been deployed. So all of those requirements then become a set of necessary components that we have to prioritize and deliver in what we call a sprint. So with Agile, we're going to be running through a number of sprints, right? The entire project duration could be dozens of sprints potentially, each sprint being typically 2 to 4 weeks in duration. So we start the sprint and we prioritize the features in the backlog. So we're going to grab a couple of functional requirements. We're going to take one of the high priority bug fixes and maybe an ops component that helps us troubleshoot or fix issues, and put those items into the sprint. Now, we are going to take and develop the code to try to address as many of the items as we've prioritized for this sprint. As we're developing the code, we're doing as much of the testing as possible. We're doing functional testing, we're doing unit testing, potentially some limited user acceptance testing, limited regression testing, to the point where we have a functional component that we can move to the deployment phase. So that component, that collection of code is then pushed into the subsequent environment, so typically a development or a QA type environment. Additional testing is performed, and then it's deployed to production, and we go into an operating mode. Now, all the while, we might be gathering more requirements. We simply add those requirements to the backlog. After we deploy the code, we do our final post-deployment testing. Perhaps there's a bug that comes out of this deployment. We capture that information, we put it into our backlog, and it gets prioritized in the next sprint. And we simply continue to prioritize, code, and deliver sprint after sprint until we're able to deliver a functional product, functional enhancement, or a complete release of our application stack. When we think about the concept or the notion of agile software development, oftentimes you'll hear this used in the construct or in the context of DevOps. And DevOps is a more comprehensive methodology that utilizes the agile software development model as a toolkit in conjunction with other tools and humans to create a consistent and functional application delivery mechanism. All right, folks, on the next video, we're going to dig a little bit deeper into the DevOps methodology. So we'll cover off on Agile and the other components that go into building a comprehensive DevOps toolkit. So I hope to see you next time. Thanks for joining us. Have a wonderful day.